Algebra 1, and I want to look at the word substitution, and I want to look at an application of that word in solving a system of linear equations. But in order to do that, I want to take a look at what substitution is and what it means, because I think it's a basic thing that we do, or a basic understanding, a basic principle in math that we use quite a bit. But I think maybe if we understood it a little bit deeper, it might help us kind of get the idea of what we're trying to do. Substitution really revolves around this symbol right here, and all of us recognize that symbol as being the equal symbol. But what does the equal symbol mean? And you could probably give me a definition about, well, they're equal in value or they're the same. But what does that look like applicationally? What does that mean if I were to apply the equal sign? And that's what I want to talk about for a minute. The equal sign, what that actually means is applicational, is that what you have on the left side of this equal sign, which is the number 5 in this particular case, and what you have on the right side of the equal sign are of equal value. And applicationally, that means they're interchangeable. I can change places without changing the value of the expression that I interchange them in. And that's a very kind of simple concept and very subtle, but at the same time it's very powerful. And I really want us to get to understand what that means. And again, what we mean is that the number 5, and this entire expression over here, this 3 plus 2, are interchangeable. So in any other expression that I have within the system, I can exchange a 5 for a 3 plus 2. And at the same time, if I had a 3 plus 2, I could exchange for a 5. So for instance, if I had a separate equation, let's say, or a separate expression, and I had, let's say, 5 plus 7 is equal to 12, well, this sign here says that the 5 and the 3 plus 2 are interchangeable. So in this second expression where I see the number 5, I can put in something of equal value. And this expression up here tells me, well, 3 plus 2 has the same value as the number 5. So I can substitute this 3 plus 2 in for this 5. So I could take the 5 out, and I could put in a 3 plus 2 instead, because this sign here tells me they are of equal value. So I have 3 plus 2 then that takes the place of the 5, and then I have the rest of the expression that doesn't change, and I end up with this expression here. Now this new expression, 3 plus 2 plus 7 equals 12, is still a true statement. It still is equivalent to this original one, because what I substituted in for the 5 is of equal value, so it doesn't change it. And then we could go the other way around too, or we could go backwards, so to speak. It says here, again, this expression means up here that wherever I see a 3 plus 2, I can exchange it and put in a 5 instead. So as I look at this second expression, I see a 3 plus 2 here. So in its place, I can exchange that for a 5. So I could then write 5 plus 7 is equal to 12. So the whole idea of this equal sign is whatever's on the left and whatever is on the right of that equal sign are of equal value and are interchangeable. Okay, so that is really the application of an equal sign. Let's look at that in terms of maybe an equation with a letter. So in this expression, you'll notice we have our equal sign, and the equal sign communicates that the expression on the left, which is a 4x plus 3y, is of equal value or interchangeable with the number 12. Now usually in a system we don't repeat numbers. In other words, numbers don't show up in both equations in the system, but usually the letter x and the letter y show up in both equations. So the valuable thing for me to do would be to take this expression that I have here and to solve it, or to isolate one of the two letters, either the x or the y, on one side of the equal sign, so then that whatever's on the other side we know would be of equal value, and we could substitute it in. So I'm going to take this expression and I'm going to solve it for the letter x. I'm going to get x by itself. So I'm going to subtract 3y from both sides of the equation here. And so that's going to give me 4x, and then the 3y is equal to 0, and 12 minus 3y. and then I'm going to divide by 4, and I'm going to reduce that, so and then this leaves me 3/4 y. Now what I have again is an expression that has an equal sign, and what this communicates is that the letter x and this expression that's on the right, 3 minus 3/4 y, is of equal value. So in any other equation in the expression, or in the system, excuse me, x can be substituted in or exchanged with 3 minus 3/4 y. And that's a very powerful and useful thing, because what that's going to do is going to take an equation that has 2 letters in it, an x and a y, and now by taking out the x and putting in something of equal value that has a y in it, I'm going to have an expression or an equation that has just 1 letter in it, which allows me to solve the system, or determine the value of the letter y. So in a situation where the letter is not already solved for, we just simply want to solve for one of the 2 letters, x or y, so that we know what that letter is equal to, or what that letter can be interchanged with. So that's an explanation of what substitution is and what the application property of an equal sign is. We're going to take a look now at how we can take that very simple property and use it to help us solve systems of equations.